Okay, guys, let's review now the practical case UK interest rates ENGDT that you can download from the virtual campus. It is based on the relationship between two financial variables. Long, which is the quarterly return of long-term UK bonds, and short, which is the analogous return for short-term UK gilts. Short-term in this case means 91 days. In this practical case, we illustrate the fact that the relationship between these two variables, which are time series, trending time series in fact, is not spurious. And second, that both time series are co-integrated. So let's start by choosing long, control-click short. Let's plot both time series. On a single graph, we see that both of them are trending. If we choose XY scatter plot with long in the x-axis, we see that there is a clear straight regression line in which the slope of the regression is very close to unity. Okay, so the relationship between these variables could be spurious or not. To test for a spurious relationship, I will add the first order difference of the variables, getting the variable d long and the variable d short. I click one of them, control click the other, and see in the time series plot that both series are now detrended. So the first order differences are more or less stationary. They are integrated of first order. If I compute the XY scatter plot between them, choosing again long as explanatory variable, I see that the regression line continues being the same. So now let's estimate these two models. First of all, ordinary least squares, short as a function of long. This is the model corresponding to the relationship in levels. Second, ordinary least squares again, d short as a function of d long. So the relationship in differences. If we put one model besides the other, we see that the coefficients are close to unity. In fact, if I compute for the model number 2 the confidence interval for the coefficient, for the slope coefficient, we see, this is the point estimates, lower bound, upper bound, 1 or 0.998553 is within this confidence interval. So this estimate is not significantly different from this estimate here. This means that the relationship between these two variables is not spurious because it is maintained when I difference the variables. Second, let's check the residual plot against time in model 1. We see that the residuals of this model show reversion to the mean. This implies that they start by being negative, but then becomes positive, then negative, positive, negative again. They move from 0, which is their mean, move up and down, but they revert to 0. They could be stationary in the mean. So if the relationship between two non-stationary variables is stationary in the mean, this means that both variables are co-integrated. Another interesting implication of this result is the following. This coefficient here is very close to 1. This means that if we write the regression equation, we could move this coefficient times long to the left-hand side of the equality. And then we would have short minus long equal this value plus the error term, the residual. This means that the difference between the short and long-term returns, this difference which is called spread in finance, is stationary with a negative mean. This negative mean implies that short-term returns are in mean smaller than long-term returns by 1.17%. So there is a term premium. If you invest in long-term bonds, you tend to obtain a return which is larger than if you invest in short-term bonds. And this is all that I wanted to tell you for today. Good night and good luck.